Okay, welcome back. This is the fourth video in the series on solutions, and in particular on utilizing the concept of molarity to make different kinds of solutions and then to utilize these solutions in the laboratory. So remember that molarity by definition is, and I'll just add that over here, so molarity is actually equal to the moles of a solute, of a certain solute, whatever it happens to be, per liter of solution. In the last video, what we learned how to do was to make a solution of a certain molarity if we know the target molarity. All right, as an example, we might want to make a solution that's 0.25 molar NaOH. And if we know the volume that we want to produce of that solution, then it's a pretty simple task to actually produce that solution in the laboratory. So as an example, if we wanted to make a 0.25 molar solution of NaOH and we knew we wanted exactly 1 liter of it, then we would take the volume that we wanted, so the 1 liter of the solution, and we would multiply that times the target molarity, so times 0.25 moles of NaOH per liter. Okay, and in this case you can see that the liter cancels, and we would need 0.25 moles of NaOH. And in order to make the solution, then we would need to know the mass of this. Alright, so this factor here is going to be over 1, and we would multiply times the molar mass of the sodium hydroxide, which is about 40 grams per mole. And you can see in this calculation how the moles then are going to cancel out, and we would be left then with mass, which in this case is about 1/4 of a mole, and would equal around 10 grams. So this would be 9.995 grams. And for just for simplicity's sake, we're going to call this 10 grams. So basically what I would do is I would go to a scale in the laboratory and I would mass out 10 grams of NaOH. Of course, I did round this, and whether you rounded it or not and whether you used an analytical scale or not, it's going to depend on how certain you need to be of the concentration of the solution you're going to make. But for certain things you're going to do in the lab, it might not matter. So we would just go mass out 10 grams of NaOH, and then what you would do is you would place this in a beaker that already has some water in it, not 1 liter of water, make your solution, and then you would adjust your final volume up to the volume you need to get to 1 liter. Now, the purpose of this video is to look at this from a different point of view. So say we had already made our 0.25 molar solution of NaOH, and now what we want to do with that is we want to actually utilize a certain volume of this solution, a certain fraction of this solution, to produce a solution, a new solution that is at a lesser concentration. So we want to take our 0.25 molar NaOH and we want to dilute it. Now, what is it that we actually want to make? So the target solution in this case now is going to be a 20 milliliter solution that is going to be 0.025 molar NaOH. Now, since we're doing a dilution, what we're going to do is utilize our more highly concentrated solution. That's the 0.25 molar solution, and we're going to do a dilution of this. So we're going to use a selected volume, and we're going to mix that with water to produce a new solution that's going to be 0.025 molar NaOH. Now, for simplicity, what we're going to do is define our 0.25 molar solution as a stock solution. All right, we're going to call this a stock solution, and usually a stock solution is the more concentrated version of the substance that we need, and we have that stored in the laboratory so that we can grab it at a moment's need in order to make other lesser concentrated solutions. Now, the thing about this is that we're going to use a formula that I'm indicating up here at the top of our screen. All right, that is M1V1 equal M2V2, and I've defined the various components of this for us. So M1 is actually the molarity of the stock solution, and V1 is going to be the volume of that solution that we need in order to dilute to make the solution that we want, which is in this case going to be the 0.025 molar NaOH. All right, so M1V1 is equal to M2V2, where M2 is the molarity of the solution that we're going to make. So that's going to be our 0.025 molar. And V2, oh, I made a typo here. This should actually be V2. So the V2 will be the volume of that solution that we need. So this 20 mLs right here is our V2, and our V1, our M2 is this value right here. All right. So to figure out how much of the stock solution we're going to need, we set up a simple equation. And the way I like to do it is like this. We're going to be solving for the V1, so I'm going to write that down. Then I'm going to have a parentheses, and in the parentheses I'm going to write the concentration of the stock solution that we already have in the laboratory, and this is going to be equal to the V2, which is our volume. Now, caution, we're in molarity, which means we need units of liters. So you're going to need to convert your milliliters here to liters. All right, and you need to just remember that 1 liter's got 1,000 mLs in it. So 20 mLs is going to be 0.02 liters. So I'm going to go ahead and insert that in our equation. It's going to be 0.02 liters. And then this will be multiplied by the final volume of the working solution that we need, which is going to be 0.025 molar NaOH. All right, now let's take a look at the units. First, I'm going to solve for the volume that we need, the volume of the stock solution that we're going to measure out. So to do the math here, it's going to be 0.02 liters, and it will be times 0.025 molar, and this whole thing is divided by 0.25 molar. Now, what's the point of me taking us all the way through this? You know, check out your units. The molarities are going to cancel, and you can see that we've actually solved for liters, which is good news because that's what we're trying to find out. And the volume of the stock solution that we're going to need is going to be 0.002 liters. Or, if we multiply by 1,000, my volume is going to be 2 milliliters. Now, in finishing, what we're going to do to actually make the final solution is, and then depending on the accuracy and the precision that we're going to need, we're either going to require for this a volumetric flask, which is shaped something like this, or a graduated cylinder. And whether you use one or the other is going to depend on literally the quality of the solution, the final solution that you're going to need. Now remember that we need 20 mLs of this. So the graduated cylinder is going to need to be able to measure 20 mLs, and the volumetric flask, it's going to be the same situation. All right, and what we're going to do to make this solution is we're going to go ahead and fill either one of these part way with water initially. All right, and then what we do is we squirt in our 2 milliliters of our concentrated sodium hydroxide solution. And then we do a final adjustment to the 20 ml mark, with our meniscus in the right location. And so we adjust that volume up to get our final solution so that it's got the right molarity given the volume of total solution. So we would adjust that final volume up. Okay, and with that, I'm going to go ahead and close.